Alrighty, GOB, let's go. So today what we're going to do is we're going to talk about one of the very last things we're going to do in measurement, talking about arc length and areas of sectors. So we're going to start off with arc length. So, the last couple of days, you've learned about the circumference of a circle, which is basically just like the perimeter. And when we're finding the circumference of a circle, we can use one of these two formulas over there, right? We could use either that the circumference is equal to 2 times pi times the radius r, or the circumference is also equal to pi times d, the diameter. So we're just going to jump in, right? If a circle has a radius of 3 meters, what's the circumference, right? So they're telling me that the radius is 3 meters. That's r. So to find the circumference, all I need to do is 2 times pi times that radius. Right? So 2 times 3, oops, if I can get this to cooperate a little bit, this is going to be 6 with a pi. Right? And then 6 pi, if I plug that into a calculator, is going to be about 18 point, we'll round it up to 8.5. Yeah. So when we're finding the circumference, right, you might remember that there are two sort of answers that we get, right? One of them is an exact answer, right? So an exact answer is when you still have pi in there, right? Because nobody knows where pi ends, right? It's 18 trillion digits long. So 6 pi is exactly the circumference of the circle. I put this little squiggly equal sign, and then I gave an approximate answer. Right? And the approximate answer is what we get when we're trying to, find a number that's a little bit easier to use, right? Like 18.85 meters that I should really put on there, right? Is a lot easier to wrap our heads around than 6 pi meters would be, right? So sometimes when, we're humans, we're trying to work with numbers that we can kind of visualize. 18.85 is a lot easier for us to use than 6 pi is, but 6 pi is more exact as an answer. Right? So quick little review of circumference, right? If I ended up having the diameter, I would just do pi times the diameter. That would give me the same thing. Right? So the arc length that we're going to talk about today is when we're going just part way around a circle. It's basically like taking a fraction of the circumference. So our formula for arc length, right, we got two different options we could use here. It's the degree divided by 360 times 2 pi r, or the degree divided by 360 times pi times the diameter. Right? So this 2 pi r right here, and also this pi d, those are just the circumference. Right? We were just working through with those formulas. Right? So basically what we're doing is we're saying, all right, I've got actually let me draw a little diagram here. It's like I've got a circle. Wow, perfect, first try. Mr. Pog, what a guy. This is the center of the circle, and let's say that I just have a little spoke here. If I'm going around this circle, that's 360 degrees. Right? If I decided to go around the very edge of the circle, that's still 360 degrees. Right? So what we're doing when we're finding an arc length is it's like we're finding a length that's part way around the circle. So, it's 360 degrees the whole way around. Let's say that I wanted the arc length of, just this chunk right here. There's 90 degrees of it. Right? So that 90 degrees, I'm trying to figure out how much of the actual circumference to take so I can turn it into a fraction. 90 degrees divided by 360 degrees will give me that fraction that I'm looking for. And then I'm multiplying by the circumference because I'm kind of cutting it down to that chunk there. Okay. Again, this might be one of those things that's a little bit easier to get once we're moving into an actual problem. So let's take a look at one. So we've got circle D down here with this marked information, right? The radius is 10 centimeters. It's never a bad idea. If you end up having a diagram, you can just mark it on there, right? That's the radius. The 60 is the degree. We want to find the length of arc FE, right? So that means that we're looking for this chunk right there. So the way that we're going to do that is we're going to take a look at those two formulas we have. We're going to figure out which one makes sense to use. We've got the radius, so what I'm going to do is I'm going to use that first one. I'm going to take the degree, which is the 60. I'm going to divide it by 360. Right? And again, what that's doing is that's telling me what fraction of the overall circle I have. What I'm then going to do is I'm going to multiply that by 2 pi r. So in this case, that's 2 times pi times that 10 that we had for the radius. Okay. So these problems can get a little bit tricky because depending on whether it's asking for an exact answer or an approximate answer, there might be more steps you should take before throwing it in a calculator, or you could just throw it in a calculator and be done. So let's explore getting an exact answer for a problem like this. So what I'm going to first do is I'm going to take a look at 60 over 360. So 60 divided by 360 is the same thing as 1 over 6. Right? We're then multiplying that by 2 times pi times 10. Well, the 2 times the 10 gives me 20 over there. Right? So now we have 1/6 times 20 pi. So, I don't know how much you guys remember about multiplying when there's a fraction involved, but we can think about that 20 pi as 20 pi over 1. Top multiplies the top with the fraction, so that's still just 20 pi up top. The bottom multiplies the bottom. So this is our exact answer, 20 pi over 6. Right. So you might be thinking to yourself like, well, Mr. Pog, couldn't we have just plugged this original thing into a calculator and gotten an approximate answer? You're darn right we could. Right, so let's see what that comes out as, right? If I just plug that into a calculator, it's going to come out as about 10.47. Okay, so this would be an approximate answer. So one thing that we should be able to do is we should be able to get to either one of these, right? They each have their uses. If I was then using this information from this circle to go on and do another math problem, keeping it as 20 pi over 6 is going to give me exactly what I'm looking for, right? It's going to help keep me as close as possible to the true value. If I go with the approximate answer, right, I've already chopped off quite a few decimal places, right? The actual answer my calculator is showing right now is 10.471975551, and it doesn't stop there. It keeps on going. Right? So taking an approximate answer can sometimes leave you, with a little bit of a wrong answer at the end of a different problem. But hopefully, these end up coming out as about the same thing. And so if you're ever unsure, you can check your work by finding the other type of answer and making sure that they come out the same when you plug them in. Okay. But that's it, right? So that arc length that I have highlighted in yellow is about 10.47 centimeters. And so that is that length that we were missing there. And that's really all there is to it, right? I know that I did a whole lot of talking through that one problem, but at the end of the day, all we're doing is we're taking the degree divided by 360 and multiply by the circumference, however we're finding that, whether it's 2 pi r or pi d. Let's try another one of these. All right, so now we've got a circle T with this marked information, right? So again, we're given a radius and a degree. I'm trying to find the length of arc PQ. Okay. So some tiny little thing to just mention real quick. When we're talking about arc PQ, it's usually talking about the smaller part of the circle that goes from P to Q, right? Technically, you could make the argument that, oh yeah, arc PQ is all the way around there, right? But a lot of the time, you're not really worried about that, right? You're more often going to see problems asking about the tiny part there. So same deal, right? It's going to be the degree, 50, divided by 360 to give me what fraction of the overall circle I'm taking. And then I'm multiplying that by the circumference. So because I have the radius, I'm going to use 2 pi r. So this is 2 times pi times 18. Okay. So 50 divided by 360. And if I wanted to simplify that fraction, that's going to be the same as 5/36. Right, 2 times pi times 18. Well, 2 times 18 is 36 with a pi. If you're getting a little bit hung up on how to simplify these fractions, like the 50 over 360, right, it does take a little bit of practice. Right? Sometimes it's if you have a graphing calculator, it's really helpful because you can say oh, I want the answer as a fraction, and it'll do it. But you could also type into Google 50 divided by 360 is 0.138888888888. You could type that into Google and say what is this as a fraction, and it'll give it to you. All right, in this case, we can also just cross off the zeros, and that works too. All right, so now I've got 5/36 times 36 pi. So it's going to be nice and easy, right? The 36 on the bottom of the fraction cancels out with that 36 we're multiplying by. Our exact answer is just 5 pi. All right. If I plugged my original thing into the calculator, it's going to spit me out with 15.71, give or take. And those are approximately the same as each other. Right? What I really should be doing is making sure that when I get my approximate answer, I put centimeters on the end of it. Right? But that's the length of that arc. That's all we need. We've also got sectors to talk about. So sectors are pretty similar, right? You might notice that it's got the same degree over 360 piece to it, but then we're multiplying by pi r squared, right? So pi r squared, remember, is the area of a circle. Right, so again, what we're doing is we're using the fraction, the degree over 360, to say how much of this circle am I taking? And then I'm multiplying that by the area to kind of like chop that down into just that fraction we're taking. Okay, so same kind of deal here, right? We're given some information here. We want to figure out the area of that sector that's shaded in with green. Right, so here, 22 is my radius. My degree is that 24. Right? All I got to do is plug it all in. Right? So the degree divided by 360, and then we're multiplying it by pi, and then r squared. So that's 22 squared. So I'm going to tell you right off the bat, when you're doing these problems with sector areas, they are not going to come out super nicely. Right? The fraction on this one simplifies down pretty okay. Comes out to be the same thing as 1/15th. And then 22 squared over on the other side is going to be 484 with a pi. So what we can do now is we can shove all this into one fraction together. We'll have 484 pi divided by 15. And that's our exact answer. But, you know, again, 484 pi is divided by 15 is not super useful to most of us. So what we can do is we can simplify that into an approximate answer. We get about 101.37. Okay. One last little thing to note on here, right? We're talking about area, right? We're finding the area of a shaded sector. Right? So in this case, this didn't give us any units. So unknown units, we can just use U. You could write out the word units. But whatever your units are, you want to make sure that they're units squared. Right? So 101.37 units squared is the area of that green shaded sector. Right? You might think like, wow, that's a lot. That seems like so much for such a tiny space. Yeah, right? The area of a sector kind of ramps up pretty quick. Right. Let's try another bit out. A sector of a circle has a central angle of 18 degrees. Right? So this one doesn't give me a circle, so what I'm going to do is I'm going to draw my own in there. Let's see. Wow, perfect circle, second try. Not too bad. I'm going to figure out about where the center is, and again, like I'm just using this as a sketch. Doesn't need to be perfect. Alright, so let's say that that was 18 degrees. That's what it's giving me there. If the radius of the circle is 30 centimeters, right, putting that on there, I want to find the exact value for the area of the sector. Right? And again, you know, you could make the argument that like, oh, the sector is this whole big piece over here. Nope. We're most often going to be talking about like these smaller sectors. Alright, so what we're going to do is we're going to try and look for that piece that I just highlighted in yellow. So same thing, right? We're going to take the degree, divide it by 360, and we're going to multiply that by the area, which is pi r squared. Right? So let's see, 18 divided by 360 is going to be the same thing as 1/20th. 30 squared, I believe, is 900, but we'll plug it in just to be sure. Nice. We got 900 pi there. And then if we smush it all together, we get 900 pi divided by 20. Gross. Disgusting. Ew. 900 pi divided by 20 doesn't really seem too nice to work with. Alright, so again, what we're going to do is we're going to get an approximate answer after that. It's going to be 141.37, and we had centimeters, and we're going to square them. Alright, so that is the area of that sector that we've got filled in with yellow highlighter. Right. With distance learning, you know, be sure to check in case your teacher is not me and they want you to do something different, but I'm pretty okay if you just jump straight to an approximate answer. It's still really good to know how to do this process to get an exact answer for things, right? Thinking a couple years from now when you're taking like your SATs, your ACTs, or whatever kind of pops up in the future, they might want an exact answer, kind of like we've been doing so far. Right? For the purposes of what we're doing, especially with distance learning, I'm okay if you skip. Like, you get this, you put it in the calculator, and it spits you out to your approximate answer. That's going to be okay.